Hi guys, let's start the last exercise of this chapter, exercise 9D. No new concepts, just the same thing, which is addition, subtraction, multiplication. So let's go and solve some questions. So question number 3, if xy, so first matrix is 1 row 2 columns, the second matrix is 2 rows 1 column is equal to 25, and then there is another set. We need to find x and y if x and y belong to whole number and x and y belong to integer. So let's start. This is a 1 by 2 matrix and this is a 2 by 1 matrix. Yes, they can be multiplied together, and my answer is a 1 by 1 matrix. So let's multiply. First I'll go with row 1 and I'll multiply it with column 1. In this case I'll go with row 1 multiply with column 1. Let's do it. So this is x, so this will be x into x plus y into y. This will give me 25. That's my first multiplication, which is x square plus y square is equal to 25, which means x square plus y square is equal to 25. That's my first equation. Let's look at the next one. So the next multiplication, what does it say? It says negative x multiplied with 2x plus y multiplied with y will give me negative 2. So this is negative 2x square plus y square will give me negative 2, which means negative 2x square plus y square is equal to negative 2, and that's my second equation. I noticed that the coefficients of y square are the same in both of them, so let me just subtract. So this is x square plus y square is equal to 25, and this is negative 2x square plus y square is equal to negative 2. Let's subtract. So this becomes positive, this is negative, this becomes positive. This gets cancelled and I am left with 3x square is equal to 25 plus 2, that's 27, which means x square is equal to 9, which means x is equal to plus minus 3. Notice that if you're taking a square root, then it will give you both the options plus minus 3. Perfect. Let's look at, so put x is equal to plus or minus 3 in, let's say, equation 1. So if I put plus 3 or minus 3, in any case it's getting square, so my answer doesn't change. So that's 9 plus y square is equal to 25, which means y square is equal to 16, which means y is equal to plus or minus 4. Perfect. Let's see what do they want me to calculate. So if x and y belong to whole number, so part 1, if x and y belong to whole number, then x is equal to 3 and y is equal to 4. And part 2, if x and y belong to integers, then x is equal to plus minus 3 and y is equal to plus minus 4. Anything else that they want? No. So let's move on. Let's solve the next question. The next question that we solve is question number 4. So let's look at the question. Question 4 says, given set 1 multiplied with x. So this is set x, not set, matrix x. Sorry, matrix 1 multiplied with matrix x gives me 7 and 6. Write the order of the matrix x. So we don't know the order of the matrix x. In any case, this is a 2 by 2 matrix. And what will be the order of matrix x? We don't know. And this is 2 by 1. 2 rows, 1 column. So for this is 2 by 2. So for these to be able to multiply, this should be equal to the first number here. So this will be a 2 by something matrix. And the solution set or the product is 2 by 1. So this is equal. This goes from here. And the second term goes from here, which means this is 1 because 1 goes here. So therefore, order of matrix x is 2 by 1. Perfect. So let x be equal to 2 rows, 1 column. So let it be A and B. So we are given 2 comma negative 2 negative 3 1 4 multiplied with AB gives us 7 6. We need to find matrix X. So just for reference sake, I will take row 1 multiplied with column 1, then I will take row 2 and multiply it with column 1. Perfect. So let's look at how we'll do the multiplication. Let's move on. So it'll be 2 into A plus 1 into B. That'll be my first term. 2 into A plus 1 into B, and the second term will be negative 3 into A plus 4 into B, and this is equal to 7 and 6, which gives me a quadratic simple equation. 2A plus B is equal to 7. Let's call this equation 1, and it gives me negative 3A plus 4B is equal to 6. Let's try and equate the coefficient of B. Let me name this equation 2. We'll multiply this equation with 4, so we'll get coefficient of B equal. So this becomes 8A plus 4B is equal to 28, and this is negative 3A plus 4B is equal to 6. Let's subtract. So this becomes positive, this is negative, this is negative. 4B and 4B gets cancelled, so 8A plus 3A, that gives me 11A, and 28 minus 6 gives me 22. Therefore, A is equal to 2. Perfect. Let's move on and let's see if what will happen if I substitute A in equation 1. So put A is equal to 2 in equation 1, and I get 4 plus B is equal to 7, which means B is equal to 3. Perfect. So I've got value of B as 3, value of A as 2. Let's see what do they want me to calculate. Question, they want me to find the order of matrix X. So this was the part that I answered. Order of matrix X is 2 by 1. And then let's look at the second part, the matrix X. So they do not want me to find A and B, they want me to find matrix X. Therefore, matrix X is 2 by 1, and this is 2 and 3. Perfect. Let's move on, and let's move on to the next question. The next question we solve is question number 5. Let me just open the question. Question number 5. So question number 5 is cos 45 sin 30. Again, we'll need to remember our values of standard angles. So let's go ahead and solve this. So I know cos 45 is equal to 1 upon root 2. Sin 30 is equal to half. Root 2 into cos 0 is root 2 into 1, which remains root 2, and sin 0 is 0. Perfect. Then sin 45 is 1 by root 2. Cos 90 is 0. Sin 90 is 1, and cot 45 is 1. So this is a 2 by 2 matrix being multiplied with a 2 by 2 matrix. So first we'll take row 1, multiply it with column 1, then we'll multiply it with column 2. Then we'll take row 2, multiply it with column 1, and then we'll multiply it with column 2. Perfect. Let's start writing. So my first term is 1 by root 2 multiplied with 1 by root 2 plus half into 1. The next one will be 1 by root 2 into 0. So that's 1 by root 2 into 0 plus half into 1. The next one is root 2 into 1 by root 2 plus 0 into 1. And then the last term is root 2 into 0 plus 0 into 1. Let's see what this gives us. Here. So the first term becomes, this is 1 by root 2 into 1 by root 2 gives me half plus half. And then this is root 2 and root 2 gets cancelled. So I'm left with 1 plus 0, which is 1. Here this is 0 and this is again half. And then the last term is 0 plus 1 into 0. This is 0. This is half plus half is 1. This is half. This is 1 and this is 0. That's my final answer. Do I have to do anything else with this? No, that's about it. Let's move on. Let's move on to the next question. So the next question that we solve would be question number 10. So let's look at question number 10. X is given as multiplication of two matrices, and we are given 2x minus 3y is another matrix. So find the matrix X and the matrix Y. Let's first multiply what is X. Let's see what do we get. So X is equal to multiplication. So for reference sake, I am again putting an arrow. First, I'll multiply row 1 with column 1, and then I'll multiply row 2 with column 1. So the order of this matrix is 2 by 2. The order of this matrix is 2 by 1. So my final solution will be of order 2 by 1. So let's multiply. Negative 3 into 2 plus 4 into negative 2. That's fine. And then 2 into 2 plus negative 3 into negative 2. So that's my matrix X. What does this give me? This is negative 6 and this is negative 8. So this gives me negative 14. This is 4 and this is 6. So this gave me plus 10. So this is my matrix X. What I know is 2x minus 3y is equal to a matrix which is given. So let's see what will 2x be. So 2x minus 3y is equal to 10 and negative 8. Let's see what 2x is. So 2 times negative 14 upon, not upon, my mistake, sorry, this is not upon, this is a matrix. So negative 14 and 10 minus 3 times y is equal to 10 negative 8. This becomes negative 28, this becomes 20, and this is, let's take negative 3y on the other side, and let's bring this matrix on this side. So minus 10 and negative 8 is equal to 3y. Let's subtract. So that's negative 28 minus 10, and this is 20 minus negative 8. That's 20 plus 8. This will be equal to 3y, which means what do I get as 3y? Let's check. So this gives me negative 38, and this gives me 20 plus 8 gives me 28 is equal to 3y, which means let's divide both sides by 3, and I get negative 38 upon 3, and the other term is 28 upon 3 is equal to y in the matrix form. Slightly weird answer, but yeah, okay, that's the final answer. We made 3y as the subject and then we divided. Let's move on. The next question that we solve is question number 15. Let's look at the question. Question number 15 is A is given as a matrix, B is given a matrix. We need to find A square minus A plus BC. So like I prefer, I will first find A square, then I'll find BC, and then I'll add all of them up. So let's look at A square first. So A square will be equal to 4 negative 2 6 negative 3 multiplied with 4 negative 2 6 negative 3. Again row 1 multiplied with column 1, row 1 multiplied with column 2, then row 2 multiplied with column 1, and then multiplied with column 2. So let's look at what would be the answers. The first one will be 4 into 4, that's 16, minus 2 into 6, that's minus 12. That's my first term. Then will be 4 into negative 2, that's negative 8, and then negative 2 into negative 3, that's 6 plus 6. And 6 into 4, that's 24, then negative 3 into 6, that's negative 18. And the last one, 6 into negative 2, that's negative 12, and negative 3 into negative 3, that's plus 9. So this 16 minus 12 is 4, negative 8 plus 6 is negative 2, 24 minus 18 is 6, and negative 12 plus 9 is negative 3. So this is equal to A square. Let's look at the next term. The next term is A, so we don't need to do anything. BC, let's calculate BC then. So it will be 0 to 1 negative 1, multiplied with negative 2, 3, 1, negative 1. Again, for reference sake, I am putting the arrow, first row with first column, then with second column, then second row with first column, and then with second column. So let's multiply. So this will be equal to 0 into negative 2, which is 0, and then 2 into 1, that's 0 plus 2, and then 0 into 3, that's again 0, and then 2 into negative 1, that's negative 2. Perfect. Then 1 into negative 2, that's negative 2, and negative 1 into 1, that's negative 1. 1 multiplied by 3 is 3, negative 1 multiplied by negative 1 is plus 1. So BC then is equal to 0 plus 2, 2, 0 minus 2, negative 2, and then negative 2 minus 1, that's negative 3, and 3 plus 1, that's 4. Done. So now let's look at the final step, a square minus a plus bc. So let's put this all together. A square is equal to 4 minus 2, 6 minus 3 minus a. A is 4 minus 2, 6, negative 3, and plus bc, which is 2, negative 2, negative 3, 4. I hope you notice that a square and a are exactly equal. All elements are equal, they are exactly equal. So they should give me a null set, but still let's check. 4 minus 4 plus 2, that will be my first term. This will be negative 2 minus of negative 2 is plus 2, and then plus negative 2, that gives negative 2. 6 minus 6 minus 3, and then the last term will be negative 3 plus 4. So this becomes 4 minus 4 is 0, that's 2. This gets cancelled, so this is also negative 2. 6 minus 6 is 0, this is negative 3, and this is 4. So that's my answer, 2, negative 2, negative 3, 4. This is equal to a square minus a plus bc. So I hope you noticed a square and a are equal. Let's move on. The next question that we solve will be question number 20. So let's look at question number 20. Question number 20 again involves trigonometry. So you will need to remember the trigonometrical standard ratio. So we need to do multiplication. So this is 4 multiplied by sine 30, which is half. 2 multiplied by cos 60, which is again half. Sine 90, which is 1. And 2 into cos 0, which is 2 into 1. This is my first matrix. The second matrix is simple, it's already given, 4, 5, 5, 4. Perfect. So let's multiply. This will be 2, this will be 1. So this is 2, 1, 1, 2. This matrix is getting multiplied with 4, 5, 5, 4. For reference sake, again arrow. This helps me understand what I am multiplying. Let's move on. So this is 2 into 4 plus 1 into 5. The next term will be 2 into 5 plus 1 into 4. This term will be 1 into 4 plus 2 into 5. And the last term will be 1 into 5 plus 2 into 4. So this will be equal to 8 plus 5, that gives me 13. This is 10 plus 4 gives me 14. 4 plus 10 gives me 14, and 5 plus 8 gives me 13. So 13, 14, 14 and 13, that's our final resultant matrix. Perfect. Let's move on and let's solve the next question. The next question that we solve is question number 21. So let's look at it. Question 21. Here we are. So A is given as a matrix, I is given as an identity matrix of 2 by 2. We need to find A square minus 5A plus 7I. So let's first calculate A square. So A square would be equal to 3, 1, negative 1, 2 multiplied with 3, 1, negative 1, 2. Let's multiply. row 1 with column 1, then with column 2, then row 2 with column 1, and then with column 2. Let's multiply. So it will be 3 into 3, that's 9, plus 1 into negative 1, that gives me negative 1. So that 9 plus negative 1, then it's 3 into 1, that's 3, plus 1 into 2, that gives me 2. Next, negative 1 into 3, that's negative 3, plus 2 into negative 1, that's negative 2. Last one, negative 1 into 1, that's negative 1, plus 2 into 2, that's 4. So this will be 9 minus 1, which is 8, 3 plus 2, which is 5, negative 3 minus 2 or negative 2 is negative 5, and the last one, negative 1 plus 4, gives me 3. So this is the value of a square. Done. Let's calculate what is 5a. 5a will be equal to 5 times 3, 1, negative 1, 2, which is 15, 5, negative 5, 10. In case of a scalar multiplication, you multiply the term which is outside the matrix with all elements. This is 5a, and then 7i. 7i will be equal to 7, 0, 0, and 7. So let's put all of this together as per the question. A square minus 5a plus 7i. Let's put this together. So a square is 8, 5, negative 5, 3, minus 5a. So that's minus of 5a, which is 15, 5, negative 5, 10, plus 7, 0, 0, 7. Let's add. We add the corresponding elements in addition and subtraction. So this is, the first term becomes 8 minus 15 plus 7. The second term becomes 5 minus 5 plus 0. The third term becomes negative 5 plus 5. Negative of negative 5 is plus 5 plus 0. And the last term is 3 minus 10 plus 7. So this is 8 plus 7, 15 minus 15 is 0. 5 minus 5 is 0. This is also 0. And then the last term is also 0. So this is equal to a square minus 5a plus 7i. This is basically a null matrix or a zero matrix. Perfect. Let's move on. We will move on to the next question. The next question that we do will be question number 22. So let me just open that question and then we will solve this question. So question number 22 says A is given as a matrix, I is given as a matrix, and we need to prove the left hand side equal to, no, another relationship is given, we need to find m. So let's look at this question. Now m, notice, is a scalar quantity. Please notice this is a small m. Small m means a scalar, a number, whereas matrices are written with capital letters. Notice these are matrices, whereas this is just a number. Perfect. So let's look at this question. A square is given equal to 9a plus mi, and we need to calculate the value of m. So first let's do a square. So a square, which is my left hand side, let's do what will be a square. That's 2, 0, negative 1, 7, which needs to be multiplied with 2, 0, negative 1 and 7. Let's do the multiplication. Row 1 with column 1, then with column 2, then row 2 with column 1, and then with column 2. Perfect. Let's move on. So the first term will be 2 into 2, that's 4, and then 0 into negative 1, so that's nothing. 2 into 0, so that's 0, and then 0 into 7, that's again 0. So this is 0. Next is negative 1 into 2, that's negative 2, plus 7 into negative 1, that gives me negative 7. The last term, negative 1 into 0, that's 0, and plus 7 into 7, that's 49. So this will be equal to 4, 0, negative 9 and 49. This is the value of a square, which is my left hand side. Now let's look at what is on the right hand side. So before we move on, I don't have to prove, so let me just write it in the form it is required. 4, 0, negative 9, 49. This is my left hand side. This is equal to 9 times a. So 9 times a, which is 2, 0, negative 1, 7, plus m times I. What is I? I is an identity matrix, which is, in this case, it will be a 2 by 2 identity matrix. So this is where it is. So let me take this term on the other side. So this becomes 4, 0, negative 9, 49. This is a positive matrix. When it moves to the other side, it becomes negative. So this becomes minus 18, 9 into 0, 9 into negative 1, negative 9, and 9 into 7, that's 63. So this is equal to m times 1, 0, 0, 1. So now let's subtract. So 4 minus 18. Next is 0 minus 0. This is negative 9 plus 9. And this is 49 minus 63. This is equal to m times 1, 0, 0, 1. Which means 4 minus 18, that's negative 14. 0, this is 0, this is again negative 14. This is equal to m times 1, 0, 0, 1. I think the answer is clear by now. What should be the value of m? Yes, it will be negative 14, but how do we show it? Which means m times 1, 0, 0, 1. Anything common between this? Yes, you can take negative 14 common, and what you left inside is 1, 0, 0, 1. Negative 14 into 1 gives me negative 14. Negative 14 into 0 gives me 0. Similarly, negative 14 into 1 gives me negative 14. Therefore, m is equal to negative 14. Perfect. Let's see what do they want me to find in the question. Let's read the question. They say find m. Figured out. So I have already found m. M is equal to negative 14. Perfect. The next question that we do is question number 23. So let me just open the question and then we'll move on. So question 23 is A is given as a matrix. Again, there is trigonometry involved in this question. So let's solve this question. Question 23 says A is equal to some matrix and B is equal to something. If AX is equal to B, we need to write the order of matrix X and find the matrix X. First, let me find what is matrix A. So 4 into sine 30. So sine 30 is half. So this is 4 into half. Cos 0, which is 1. Cos 0, which is 1. And 4 into sine 30, which is 4 into half. So this is 2. This is also 2. So my matrix A is 2, 1, 1, and 2. Done. So I know what my matrix A is. Let's see what else is given. So as per the question, A multiplied by matrix X. So 2, 1, 1, 2 multiplied with X will give me 4, 5. That's my matrix B. That's what as per the question. Am I missing something? No, this is fine. So what is the order of this matrix? It is 2 by 2. What is the order of this matrix? It's 2 by 1. So what will be the order of matrix X? This will be, let's say, A into B. So 2 will be equal to A. This row goes here and this column goes here. Therefore, order, so this is my first part, order of X will be equal to A is 2 and B is 1. So 2 by 1. Perfect. So now let's take let's take the value of X. So let X be equal to 2 row by 1 matrix, which means let X be equal to, let's say, X and Y. Perfect. Let's multiply. So 2, 1, 1, 2 multiplied with X and Y gives me 4, 5. I think this time I'm going to get a quadratic. There's no 0, there's no negative, so I don't think they're going to cancel out. Let's look at this. Row 1 gets multiplied with column 1, and then row 2 also gets multiplied with column 1. So let's multiply. So this will be equal to 2 into X, that's 2x plus 1 into y, that's y. Next is x, 1 into x, that's x, plus 2 into y, that's 2y, and this is equal to 4 and 5, which means this gives me two equations. 2x plus y is equal to 4 and x plus 2y is equal to 5. Let's name this equation 1 and let's name this equation 2. Let me multiply this with 2 to equate the coefficients. So this is 2x plus y is equal to 4 and this is 2x plus 4y is equal to 10. Let's subtract. Minus, minus and minus. This gets cancelled. Y minus 4y, that's negative 3y. 4 minus 10, that's negative 6, which means y is equal to 2. Put y is equal to 2 in equation 1. I get 2x plus 2 is equal to 4. 2x is equal to 2. Therefore, x is equal to 1. Done. So x is 1, y is 2. Let's see what's the question. The question says find the matrix X. Let's write this. Therefore, matrix X. Please note, if you leave your answer at this form, you lose 1 mark because they want the answer in the matrix form, which means 1 and 2. Simple, isn't it? Perfect. So that brings me to the last question of this chapter, which is question number 25. Let me open that question and then we can move on. So the question says matrix B is given as something. We need to find X if X is equal to B square minus 4B. Good. So let's look at X. 25. This is B is given as something and X is equal to B square minus 4B, and then there's a tail question. So if X into there, so there are two multiplications involved. So let's do the multiplication there. So first let's find B square. B square will be equal to 1183 multiplied with 1183, row 1 with column 1, then with column 2, row 2 with column 1, and then with column 2. Perfect. Let's multiply. That's 1 into 1 is 1 and plus 1 into 8, that's 8. Next, 1 into 1 is 1 and 1 into 3 is 3. This 8 into 1 is 8 plus 3 into 8, that's 24. And the last term, 8 into 1, that's 8 plus 3 into 3, that's 9. So my B square will be equal to 9, 4, 24 plus 8, that's 32, and 8 plus 9, that's 17. This is equal to B square. And what's 4B? 4B will be equal to 4 times B. This one is simple. So this is 4 times 1183. So this will be equal to 4, 4, 32 and 12. Perfect. So this is 4B. And I know X is equal to B square minus 4B, which means it will be equal to 9, 4, 32, 17 minus 4B, which is 4, 4, 32 and 12. So this is a 9 minus 4. This is 4 minus 4, subtracting the corresponding element, 32 minus 32 and 17 minus 12. This is equal to X. So 9 minus 4 gives me 5, 4 minus 4 gives me 0, 32 minus 32 gives me 0, and 17 minus 12 gives me 5. So this is equal to X. Now there is the second part of the question. So X multiplied with AB, another matrix, is equal to 550. So we need to find the value of A and B. So let's substitute X here. So this is 5005. This multiplied with AB will give me 5 and 50. Perfect. So row 1, then with column 1, and then row 2 with column 1. Perfect. Let's multiply. So that's 5 into A plus 0 into B, and then 0 into A plus 5 into B. This is equal to 5 and 50. So this is 5A and this is 5b. This is equal to 5 and 50. So this tells me 5a is equal to 5. This means 5a is equal to 5, which means a is equal to 1. And it also tells me 5b is equal to 50, which means b is equal to 10. Let's say, what do you want me to figure out? Solve for a and b. I have solved for a and b. This gives me my final answer. Perfect. That brings me to an end of this chapter. Let's look at some homework question. Homework question for exercise 9D. So you should solve question number 7, question number 9, question number 13, question number 17, question number 18, and question number 24. I hope you realize by now that addition was absolutely nothing. Multiplication with scalar was also nothing. The only thing which you need to remember is how to multiply. That's why all these questions I have been making an arrow, row 1 with column 1, then row 1 with column 2, row 2 with column 1, row 2 with column 2. That's about it. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.